All right, so welcome once again to the continuation of our software development class. Remember that what we're trying to do is to build the groundwork for the software that we are going to be developing, both in the class, both in our own personal vocations, and when we join any organizations. Those skills will be the ones that we will transfer or bring to the table, as people say these days. So the last time we met, we talked about life cycle models, and we pretty much went in depth into what the recommended life cycle models are. We talked about the traditional, which is the plan driven model, and then we talked about the agile model from a category standpoint, right? We started talking about the standard life cycle models. They help us to mitigate failures in software development. We highlighted three main reasons why software efforts fail. We said you could build the wrong functionality. That is, you build something that your user did not require. You might have quality problems, which means that your software did not meet the user's expectation or your customer's expectation, and then there may be schedule delays, right? You plan to told the customer that you will be ready 1st of January. It's now the 31st of December, and you are still not delivered. So these are the three main areas that a software development efforts can fail, right? And take note of this. Take notes of these failure points, because we will be touching on them frequently as we move on. And the reason is, if we can mitigate this failure, we can produce software that meets our users' demand. And we said that one of the ways that will help us to mitigate these failures is to use standard life cycle models, right? So we said that this model would help us to mitigate failures in software development. And this means that having a good working knowledge of this model is imperative, right? The model should serve as a guide as you approach any software development project, regardless of what the size or the complexity is. You could be doing the smallest of projects, right? It might just be something that you are doing by yourself, or you could be involved in a geographically diverse team, and your project is complex. Regardless of what level of project you are doing, just put these life cycle methodologies, these life cycle models, put them at the back of your mind to serve as a guide to lead you through those projects. And then, I started saying the word projects during our last class. Okay, I don't want you to get things mixed up. When I'm talking about projects, I'm talking about your software development effort, using a project-based mentality to produce the software. Okay, and there's nothing, there's nothing special about There's nothing special about the word projects. It's the same kind of word that you know or you use when you talk about projects outside the scope of software development. When you talk about you're building a house, right? That's a construction project. You're doing something around the house. You want to put out a deck, or you want to put in a new faucet. That's a DIY project. So it's the same thing. And knowing what a project is, right, would help us see why using a project-based mentality would help us to build quality software. So what we are saying is, we are trying to build this software. We are going to use the software, the life cycle models, right, in a project environment. Okay, and what is a project? A project is just a temporary endeavor undertaking to create a unique product or service or a result, right? It's temporary. It's supposed to lead you into getting a product. Okay, your software is a product. Okay, and it's also, the efforts to create the software is also temporary. You're not going to keep working on the software or working on developing the software. Okay, you're not going to work on developing the software for eternity. You will always have to end the development phase of the software at some point. So the software development is also a temporary endeavor. It creates a product that you can now use as long as it's available to you. Okay, so don't let's get those two things confused. There's a development part of creating a software, which is what we are concerned with. Once the software is created and you release it to your users, they keep using the software. That's another phase, right? So when I say a software development effort is temporary, I mean creating the software itself is a temporary endeavor. Okay, and this temporary endeavor, it's helpful if we don't just approach it haphazard. It's helpful to have a structure or a scaffolding, or let's say a map that will guide us into making sure that we are complete. And this map or this guide that we are going to use, we are saying that it's the life cycle models. Okay, so now before we start going into different life cycle models, for any project there are 4 things that are core functions of any project, right? Now those 4 things, give me one quick second as our whiteboard loads. We should have somebody in the class that will wipe the whiteboard every time we are done with class. That way we don't have to do it the first thing every time. We should have a class whiteboard wiper, and it's going to be somebody that does not turn on their video. That's going to be the class whiteboard wiper. As I was saying, there are 4 core functions for any project, right? I know I'm going on a tangent, right? But please try to follow the thought. I'm jumping from life cycle methodologies, and then I'm now talking about projects. But everything works together. And if you follow my thoughts, you would see where I'm going with this. And if you have any question, like if I've lost you, if you are still on the life cycle model train, right, and you are thinking, what are you talking about projects? Why are we talking about projects now? Just bring me back, right, and let me know that I've lost you at some point. We defined what a project is. We said it's a temporary endeavor, and the goal is to create a unique product or service or result, right? Now there are 4 core functions of any project, right? You talk about the scope of the project. You talk about the time constraints of the project. You talk about the cost of the project, and then the quality of the project. Now, of these 4 functions, right, 3 of those ones are kind of self-explanatory. I don't have to spend a lot of time. What I'm going to focus on is the scope. And really, this is why I took a detour to talk about projects at this point, right? When you talk about the scope of any project, right, the scope is what defines the boundaries of that project, okay? And boundaries keep things in. What should be in, it keeps them in. What should be out, it keeps them out. Okay, so if your project is supposed to do 1, 2, 3 things, right, it means that the scope of your project is the 1, 2, 3 things that you have to do. Okay, 4, 5, 6 is not in scope for the project. If your project is supposed to do 1, 2, 3, okay, so just know that the scope of any project is the boundaries, what determines what is in, what comes in the project, what you are supposed to be doing in the project, as opposed to what you stay out, right? That's the scope of any project, right? Every project has a time allotted, right? Sometimes 6 months, sometimes 6 years. It depends on the complexity of the project. Then there's always a budget, right? A project is never open-ended. Now, I say that with a little bit of caution because there are some customers that have deep pockets, right? But at the same time, you must be mindful of the budget of any project. Then you have the quality. Does it meet the specifications that you have designed it to do, right? This is not a project management class, but I wanted to touch on this, especially from the perspective of scope, because we are now going into software development and we will be dealing with scope in every part of our software development effort. Okay, so now we are going back into life cycle model. Now let's look at a life cycle model. Let's start looking at different life cycle model. But first, the first thing that I'm going to discuss is one model that you should really steer clear, right? You should not be using this model at all. Okay, so and you'll be wondering if we shouldn't be using it, then why are we talking about it? That would be a fair question. But the reason I'm talking about it is this is the model that we all gravitate towards, right? Because one, maybe we have not prepared enough, maybe we are running out of time, or maybe we just think that, you know what, requirements design, that really doesn't matter a lot, let's just write code and forget about it. Okay, that's why I'm showing you, so that you can know that once you are falling into the trap of this type of model, you should wake yourself up and use a more standard or more correct model. So this first, not a model, is called code and fix. Okay, now all you do in this model is you take the most minimum amount of time to understand your problem, the business problem, the idea you are trying to solve, or the business problem. You take as little as you can amount of time to understand the problem and just go straight to writing code. After you have written your code, you compile the code, right? And then you try it out. You try out that code. Now, if the code doesn't work, you fix whatever problem is telling you that is not making it work, and then you try it again. Then you continue this cycle. You write code, you compile, you run, it errors out, you fix the error, and then you check again, and then if you find another error, you fix another error, then you code to fix the error, you compile, you run, and you continue this cycle until you don't see any error anymore. Then you ship your program to whoever wants to use it. Again, this is a model that you shouldn't be using. But what happens is we are working by ourselves, or we are working on very small projects. This is easy. It's an easy model to gravitate towards, right? But again, please do not use it, because there are no formal requirements, there is no documentation, you are not testing anything, there is no quality assurance, then your release is haphazard, right? There is no schedule. Now, the only case that I can make for this particular model is if you have what we call a POC. In the software development world, there is something called POC, and POC just means proof of concept. Okay, the proof of concept is, let's just assume, the closest synonym I can give for a proof of concept is a prototype, and yeah, I use that very loosely. So a prototype, that's the closest that I can get for a synonym for proof of concept. Now, a proof of concept is you have an idea and you want to quickly demonstrate your idea without going through the whole process of building the software. You just want to demonstrate that your idea works, right? That's a POC. Okay, now for a proof of concept that you will just build the prototype and discard it immediately, yes, this code and fix model will work. So that's about the only point that I can make an argument to use code and fix. Now, I would remind you, when we start writing our program, our database program, and you are given a problem, and before thinking about it, you have started writing code, right? You have just started writing. Before even you think about it, you have started writing code. At that point, I will remind you that what you are doing is code and fix. Okay? So, don't worry, I would remind you of that. But just understand that there is a model that you should not be using, and that model is actually not a model. As contradictory as it is, I hope it makes sense. So let's leave the not a model and go to our very first life cycle model. Now, the first traditional model that we are going to talk about is called the waterfall life cycle model. Okay, you can see that it looks like there's a waterfall. If you look at the way the phases. Now, the first thing that I want to point out before we go into discussing the waterfall methodology is, first, if you look at the way things look, you look at the direction, it looks like a waterfall. That's where it derives its name from. Now, each of these rectangles is what we refer to as phases, okay, of the waterfall. It's one phase, multiple phases, right? So in a waterfall model, you can see that you have your conceptual development phase, where you have the idea, you gather the requirements. We talked about what requirements are. You do a design, you do a detailed design. This is where you write your program, and then you start testing, then you release, and any maintenance that you have to do. So that's the waterfall model, right? So it's the first and the most traditional plan-driven process model, right? It was created in 1970. Not that this matters anything. Nobody's going to question you on where. It's not. We are not doing project management, but it's just good you know these things, right? It was created in 1970 by someone called Winston, if I can spell it, Winston Royce, right? Okay, so this model addresses all the standard life cycle phases. Okay, so you have from your conceptual phase all through to when you release your software to your users. All the phases are present in the waterfall model, right? As we have talked about, it progresses nicely through requirement gathering, analysis, to architectural design, detailed design. You code, you debug, you test, your system testing, both unit testing and integration testing, then you release, and then the maintenance phase, right? Now, each of the phases require detailed documentation. Okay, so in your conceptual phase, you would have a detailed documentation and analysis of that documentation, reviews. You have to, once you review, then you have to sign off each phase. Conceptual design, requirement analysis. Once you complete each phase, you have to sign off. All right, and a sign off is between you and your customer, you and the user, saying that you have captured everything that should be applicable to that phase, and both the developer, the software developer, and the user base, both of them have the same understanding of what that phase is supposed to be doing. So, in our way of speaking, we would say that both the user and the software development team are on the same page. Okay, so after your review, that's when you have the sign off. But you sign off each of the phases. Once you sign off each of the phases, you archive the document. So this is a heavily plan-driven methodology. Okay. Now, there's a sign-off at each process phase, configuration management and close management of the entire project. Okay, so you have a high-handed, sorry, it's not high-handed. You have a high level of documentation in all the phases. Okay, and it is based on that documentation that you communicate with your user. All right, but we are going to talk about this, but I just want to make sure that you understand that when I say a user, it can be an individual, but not necessarily an individual. Okay, individual. Right, your user can also be a corporation, all right, or an organization. So when I say a user, I'm using that user, and I'm using that word in a very generalized term. I'm not just referring to one person. I'm referring to anybody that is going to utilize your product. There's a name for them, and there's a more technical name for them, and we'll get to that in a few minutes. Okay, so you have to document, communicate with your user base with all the documents that you have developed in all these phases. So let's say we are in the requirement phase. You document everything, you review it with your user, and you now get your user sign off. Then you archive the documents. Okay, so you can see that there's a high level of documentation, and this is why we call it a plan-driven process. Okay, now with all this documentation that we have talked about, how detailed you have to be in order to make sure that you are following the waterfall methodology. One thing about the waterfall methodology is that it doesn't work. Okay, so it doesn't work. You saw it right. So you'll be surprised that yeah, you do all that detailed work and you're asking the question, why am I saying it doesn't work? Okay, now let's look at the reasons why I say it doesn't work. Now, note one thing, right? Although I say it doesn't work, it's a good learning process. Because if you know the phases of the waterfall life cycle model, you will know all the phases that you have to go through for any software development effort. Okay, it's a good teaching process. It's a good teaching methodology. You can learn all the steps of the software development lifecycle model from the waterfall model. Okay, so why do I say it doesn't work? I'm saying it doesn't work because, or let me preface it by saying it's good in theory, but when you get to the field on a practical level, it doesn't work. I think that's a better thing to say. On a practical level, it doesn't work, right? Because the first thing is the waterfall methodology generally requires that you completely finish a phase before you continue to another phase. Okay? In theory, that is a nice thing, but from experience in practice, there is no way you will know everything that needs to be known in a phase. Okay? So, you never know all the requirements. In fact, your user that you are creating the software for will not even know the requirements by the time they are telling you the requirement. They won't know the full requirement, which means that they can tell you a requirement today, and the very next minute they would want a change to that requirement. And that is just telling you that there are so many unknowns. So there is no way for you to completely finish a phase like the waterfall is advocating before going to another phase. That's number one. The second reason why the waterfall will not work is, if you look at it, it's only a forward movement. You finish conceptual development, you move to your requirement phase, then you finish that, you move to your architectural design, right? Then you finish that, you move to detailed design, and so on. You cannot go back. There is no way of going back to a previous phase. So let's say you have finished requirement and you have started design. Then your user comes and tells you, you know what, I want to make a change to the requirement. The waterfall process does not have any mechanism of going back to the previous to the previous phase, just because when it was designed to model the assembly line mentality of developing stuff, right? During the manufacturing era, you had a lot of assembly lines, right? If you go to automobile manufacturing companies, right, they have more of an assembly line where things just move on a conveyor belt, and then it just keeps moving, and the parts will be worked on as it's moving on that belt, right? When this model was designed, it was designed to model that particular type of mentality. Okay, so that's why those are the reasons why your waterfall methodology will not work. Okay, so if it doesn't work, although I'm saying it doesn't work a lot, but I don't want to take my it doesn't work in context. Make sure you understand the context of why I'm saying it doesn't work. And the reason is, the waterfall methodology is something you should learn. Actually, you should learn it by heart. Because if you know all the steps in a life cycle process, you will be able to adapt to any one that you use. And the waterfall is the one that contains all the life cycle phases. So learning this is still important. All right. So if it doesn't work in the practical sense, then what do we use? So an improvement of the waterfall is what we call the waterfall with feedback. Okay. So we're talking about the straight line of the waterfall that doesn't work because there is no ability to back up to a previous phase when you discover a problem in the current phase, right? Now, the waterfall with feedback tries to address this problem. Okay? Now, it creates a way of going back to the previous phase. Although you still complete a phase before moving to the next phase, but with the feedback, you have the option of going back to a previous phase once you complete that phase. Now, this sounds like it solves the problem of the waterfall, but then it creates another problem, right? Because there's an issue with scheduling. The waterfall with feedback can mess up your scheduling. It can mess up the project schedule, right? And the reason we are saying that is there can be an unexpected move back to a previous phase of development, and that will tell on your schedule. Okay, and then also, if we keep moving back to another phase, which means we will move back to that phase, complete the phase, and then come back to the phase that we were before, work on that. If we don't have a problem, rather we move ahead. But if we get to the next phase and we remember that the previous phase, we have to fix something in the previous phase, then we have to go back. Then it makes it harder to know when you are finished. Okay? So that's where there is an issue with the waterfall with feedback. Although it improves the waterfall model, but you still have a problem with schedule, and then you don't really know when you are done. Okay? Now, that brings us to what we refer to as the incremental or the iterative process model. Yes, please. All right, so we're saying that we've seen the shortfall of both the waterfall and the waterfall with feedback, right? So in the traditional model, we are saying that these are the examples of the process models in our traditional plan-driven models. But we have seen that they fall short from a practical perspective, right? And it's because the best practice when you are dealing with any process model is to iterate and deliver incrementally. Okay, and that's why we are saying that the incremental or what we call the iterative process models, they are actually our best practice. Okay, so what this means is you have an incremental mindset in working on the software you are developing. So you treat each iteration, right? What you're doing is you are iterating over different phases. So we are not saying you are jettisoning the phases. You are still using that phases, you are still using the phases, which is why I'm still saying you need to learn those phases. But in an iterative approach, what you are doing is you are treating each iteration as a closed-end mini project. Okay, so for every iteration, for one iteration, that iteration, you will treat it as a mini project. So it means you have one whole project that's your goal, right? In this one whole project, you now divide that project into mini projects. So we have divided this one project into like 4 mini projects. Okay, and in these 4 mini projects, what we are trying to do is we will do complete requirements in the mini project. We will do design. We will code. We will test. We will test, and then we won't release, because releasing is releasing to our users, right? But what we do is we'll deliver this project internally. We deliver internally. Okay? Because the user is looking for the whole pie. We splitted the pie into 4, and we are saying that we are going to take each one and incrementally develop each one. We develop 1 first, then develop 2. By the time we develop 2, we are half done, and then we now take 3. We are 3/4 done, and then we now take 4, which is the whole pie, right? That's why we call it incremental, right? But in the incremental model, we are iterating through all these phases. For number 1 part of the project, we will do requirement, design, code, test. We'll deliver internally, 1 iteration. The next one is our 2. That's another mini project. We will iterate through the same steps to deliver 2, right? Then we move to 3. We will iterate through the phases. We'll create 3. We move to 4. We will iterate through the phases, and now we have the whole pie. Okay, so that's like the gold standard. That's the best practice for any process model or for any life cycle model. Okay, so for every iteration deadline, at the end of each iteration, right, you deliver the fully tested, fully integrated system to your stakeholders, your internal stakeholders, right? So that's what I was talking about here. What you do after your iteration, after each iteration, you deliver to your internal stakeholders. Okay? Now, I said internal stakeholders. They are not your customers that requested the whole solution, right? They are people that manage the software development process in your organization, because what you are doing is you are trying to build the product incrementally. All right, so a stakeholder is nothing but any individual or group or organization who may affect or be affected by or perceive itself to be affected by a decision, activity, or outcome of a project. Look at that definition. The stakeholder, any individual, any group or organization, they may affect the project, they may be affected by the project, or they may perceive themselves to be affected by any decision made of a project. Okay, so if anybody or any organization fall within this rank, they are stakeholders. Okay, so that's why you choose your internal stakeholders. By this definition, you know that stakeholders can be internal, they can be external. They can be internal to your organization, or they can be external. And your user, your customer, they are a part of your stakeholders. Okay, so just note that distinction, and note how your incremental process, know how they work. Okay, so while the waterfall with feedback recognizes that all the requirements are not typically known in advance, and that you can make mistakes in your design, it doesn't go far enough in taking those realizations into the process. But the iterative model will make this required change in your process steps. It will make it more explicit, right? And it creates a process model that builds your product, which will be your software, a piece at a time. Okay, so for any iterative model, right, what you do is you take the known requirements. Remember, we are saying that in the waterfall model, you have to know all the requirements, finish all the requirements, and then sign off on those requirements. But for your iterative process, your incremental process, what you do is you take the known requirements, the one you know, early in the process. Okay, so you work with what you know for your iterative process, right? We call that taking a snapshot of the requirement. Okay, it's like you take a picture in time of your requirements, right? So we say that you take a snapshot of the requirement, because you can only develop based on what you know. You should try your best not to develop outside of what you know. Okay, so the first thing you do for an iterative model is you agree that there are unknowns. You agree that the only constant is change. But even at that, you take the requirements that you know. Then you prioritize these requirements. So the first thing is you take a snapshot of the requirements early on in the process. The second thing is you prioritize the requirements. Okay? Understand what we are talking about. We are talking about an iterative model as opposed to a plan-driven traditional model. Okay? So after you prioritize, then before I go there, you prioritize the requirements based on the customer's ranking. It's not based on what you think, right? In any software development effort, your customer or your user comes first. Everything you are going to be doing must be tailored towards the user, because you creating the software, even though you think you have the technical knowledge, you are not the one that is going to use your end product. You are developing it for someone, right? So if all your opinion is what you develop the software with, there's a high probability that it will get to the user, and the user will not like what you have produced. So prioritize based on the customer's ranking. Let the customer tell you what feature they want first. Okay, what is the feature of that software that you should produce first? So your prioritization must be centered on the user's perspective. Once you do this, then you pick the highest priority requirement and then plan your iterations. Okay, so you pick the highest requirement, and then you plan your iterations. Remember, each iteration, as we say, is a complete project. We said we treat an iteration as a mini project, which means you go through requirement, design, code, test, then you deliver. All right? So for each iteration, you would then go back to your prioritization list and pick the next. So you pick the highest, you pass it through. All right, so let's say 4 is you do a mini project. That's an iteration. Okay, then the next thing you do is you just pick the next highest, and then you continue the cycle until you create the entire product. Any question? So the whole idea is, we are not saying the traditional plan-based model is worthless and we should just throw it away, or all we just need it for is to just read and know what the phases are. That's not what we are saying. What we are saying is there's a place for the traditional model. There's a place for it. Companies use the traditional model. There's a whole ranking system on the traditional model. So many agencies use the traditional model. We are saying that even if you opt for the traditional model, you should always try to make it incremental and not just follow the pure traditional model that will not give you the flexibility of returning to a previous phase or will mess your schedule. As long as you use that traditional model in an iterative setting, meaning that you take a part of the project, turn it into a mini project, go through all the phases of the life cycle, iterate on the next mini project the same steps, iterate on the next mini project the same steps until you get a whole product. That's what we are talking about, the incremental process model. Okay, so by doing a complete project with a subset of the requirements every time, at the end of each iteration, you end up with a complete working and robust product, right? Now, each iteration will give you fewer features than the final product, but that's fine because you will continue your iterations until you get to all the features that should be in the final product. Okay? Now, so in our traditional based model, so what happens if you get the estimates, if you get the time estimate or even the budget estimate? Let's say you estimated that this was going to be a 6 months project, or let's not go on the macro level. Let's go into our iterations, because now we are talking about different iterations. We told our user that we are going to have this particular software in 6 months, but we have decided internally to use an iterative model, an incremental model, and we split it into 4. So we have 4 mini projects in these big projects. Then we begin to estimate. We say for that 6 months, we will use 2 months for the first, 2 months for the second iteration, 2 months for the third iteration, 2 months for the fourth iteration, right? That's 8 months. We have already overshot our 6 months for the total project. So that's what I'm saying. What if you get that estimate wrong and your mini projects make you go over? Okay. Now, what if you decide to include more features in your iteration that makes your project go over? Because these are things that happen. These are not just conjectures. I'm not just guessing these questions. These are real life questions that you will face when you are working on a project, right? You get your estimation wrong, you put in more features into an iteration, and that iteration ends up going longer than you expect, pushing the whole project timeline forward. All right? What if there is an unexpected delay? Something just happens that delays the process, right? Well, that might look like you won't make your iteration deadline. So, in cases like that, there are 2 realistic alternatives that you can use when you start getting into issues with your iterations, right? There are 2 things that you can do at that point. One, you can move the deadline. Okay? You decide that our 6 months for the total project is not realistic. You talk to the user and you move the deadline. Or the other thing you can do is to remove features. Okay? So in all this, what I'm trying to pass across is you should be adaptable. At the same time, the process model helps you to communicate with your user. At the end of the day, you want your user to be satisfied. You want to create, they've come to you with a problem and they've asked you to create a computer program to solve their problem. You want to make them happy. You want your solution to meet what their expectations are. So in doing this, you have to be adaptable and you have to be flexible, knowing that the process model you are using is a tool. It's not a you are not married to your process model, right? It's a tool for you to use to make your software developing life easy. So just understand that you have alternatives. You should be as adaptable as you can. Okay? Questions? If there are no questions, let's move back to the slide. All right. So remember that we are still talking about the traditional plan-based life cycle, right? We now see that an iterative approach is more practical, just like we said earlier on. We are still using the traditional base, but an iterative model is practical. So it begs the question, can we implement an iterative or what we call an incremental approach while using the traditional model? Yeah, the answer is yes, and we have answered that question. But a good model, a representative model of the traditional life cycle process using an iterative approach is what is called evolutionary prototyping. Okay? So, the evolutionary prototyping is the traditional way of implementing an incremental model. The requirements are prioritized as they are received, right? What this does is it produces a succession of increasingly feature-rich versions of the product. Okay, what we are saying is this particular type, just like the waterfall is a type, this particular type of lifecycle model is best fitted for an incremental approach. And everything that we have talked about an incremental approach is what is used in this particular model. The name is just called evolutionary prototyping. Evolution, it's incremental as it is, right? So you prioritize your requirements. As you are prioritizing the requirements and going through your mini projects, it produces more feature-rich versions. So you are putting features into the product. The features are becoming richer and richer and richer until you create the whole product. Okay. Then you refine the model. You refine the version depending on the feedback the customers give you and the result of your testing. Okay. So you keep refining the product. It's an excellent model for an environment that is changing or when requirements are ambiguous. Like we said, we will never know all the requirements, right? You can use the evolutionary prototyping for things like that, right? So this particular model is what evolved into the modern agile development processes. Okay, so you see that we started with the strict traditional plan driven, we moved to the iterative, and the iterative is what evolved into what we call the agile methodology, which is the next category of process models. Question? Okay, so agile. We've been talking about agile. All right. First thing I'm going to do is I'm going to do a Google search because it's an English word. What is agile? Not agile methodology, the word agile itself. No, I want agile definition. Okay. According to the dictionary, agile is an adjective and it means able to move quickly and easy. Okay, so that's what agile is. So we know what it is right now, and by knowing what it is, we have an idea of why we are going to, or we will use that as a process model to be able to develop our software. If anything can make us move quickly and easily, right, it means that we can develop faster, right? We can do things quicker, and with this way we will be able to push our products out faster, our customers will be happier faster, and everything would work out fine, right? By the way, a lot of companies, a lot of processes, a lot of organizations are using the agile methodology right now. Every company that you can think of in the face of the earth uses this methodology to deliver or to develop software. Your Netflix, in fact, they are agile on steroids. Your Amazon, your Facebook, all these companies depend on the agile methodology to develop and deliver software, and it just stands to reason that for companies that need to push out software really quickly, right, they can't be bogged down with processes, they can't be bogged down with documentation, they can't be bogged down with bureaucracies, right? The faster to market that you are, the better it is for you from an economic standpoint. And if there's a methodology that can make things faster, then that's what people are going to use. And that's what brings us to the Agile methodology. Okay? So, the Agile methodology allows you to release completed software more quickly than the plan-driven methodologies, which is why we call them Agile, right? They are lightweight. They are called lightweight as opposed to the heavyweight traditional model. And they are called lightweight because there's less documentation. In the plan-based methodology, one of the drawbacks of the plan-based methodology is the fact that there is heavy dependence on documentation. In the Agile methodology, there is less documentation, right? The reason for it's not that we wouldn't document stuff. It's not that we are not trying to be as thorough as possible, but with Agile development, the main idea is that the goal of any software development project is a working code, right? And because the focus is on working software, right, then the development team or the developer should spend most of their time writing code and not documents. That's the principle of the Agile methodology. If the central goal is to be able to deliver software, then you should be writing software and not writing documentation. Okay, that might seem like we are telling the business analysts that they have no place in the software development process. But that's not what we are saying. What we are saying is your code should be document enough for whatever project you are doing. Your code should be self-documenting. So you should use all the standard tools available to you. Your code should be written according to industry standard. You should document your code. You should use comments. We are going to talk about all this. We are going to use all these concepts so that when we start talking about commenting in your code, you will know the reasons why they are important, because there is no other document than what is in your code. All right, so just understand that that's the reason why the Agile methodology is called lightweight, because there's not an heavy dependence on documentation, right? So because they are lightweight, they emphasize writing tests before code, right? You write your tests before you even start writing any code. It's kind of counterintuitive, because if you have not written the code, what will you test, right? But then the Agile methodology they depend solely on what we call test-driven development, right? It's something that you should be familiar with because it's a best practice. It's called test-driven development. And because this is software development, we have to put an acronym. It's TDD. Okay? When we start talking about the types of Agile methodology or the types of Agile processes, we would explain what test-driven development is. Actually, let's explain it now. It makes things easier. Test-driven development just states that when you get your problem that you're trying to solve or you're trying to write code for, you write out everything that you want to test. If you want to write a program that adds 2 and 2 together, right, to make 4, okay, you should write a test making 2 and 2 to not equal to 4, to equal to something like 5. So that by the time you write your program, right, your program should fail if the result is 5, right? So what it's trying to tell you is you can start writing your tests to test. When I say test, I mean testing the functionality of your code based on the requirements. Once you write the test, definitely before you write the code, the test will fail. That is assured. That is something that would happen, because what you have done is you have written the test, you have not written the code. The test will definitely fail. But as you are writing the code and passing it through the test, some of the test will start succeeding. It will start passing, and that is why the test-driven methodology, the test-driven development, is highly required in the Agile methodology. Okay, so you write tests before code, you release your product frequently, then your customer is highly involved in the project. Because you are working in an Agile methodology, you cannot wait for a letter written to the customer or a phone call to the customer. Most Agile processes require that the customer are on site with you. Okay, so your customer is heavily involved in the project. You are developing the project. They are also testing on their side. They are looking at the features that you are putting in their software, making sure that the features are what you have said it will do, and then they can give you feedback immediately, right? The bureaucracy is removed. So, and there's common code ownership, right? You can write code to make it simpler and easier to maintain. So you can see that in the Agile methodology, things move very fast. People get decisions immediately. You do something, you test it, you get the result immediately. You get the result, you ask the user for their feedback. She gives you the feedback. You get the feedback right there. There is no going back and forth or anything. There is nothing delaying communication between you and the customer, because they are right there and things move faster. Okay? So, the first type of Agile methodology that we are going to talk about, the first type is what we refer to as extreme programming. Extreme programming, or XP. Okay, that's the first one we're going to talk about. Now, extreme programming was created around 1995, right, by Kent Beck and Ward Cunningham. Again, these are just for your educational knowledge, right? Extreme programming is a type of Agile programming that is development focused, is highly development focused. As you can see from the name, extreme programming, right, is lightweight, efficient, low risk, flexible, predictable, scientific, and fun way to develop software. Right? It has a heavy customer involvement. You are always testing, always testing, always testing. It uses the test-driven methodology. And one thing about extreme programming is what we refer to as pair programming. Okay. Now, pair programming just takes the adage that says two heads are better than one. So you have two programmers that are developing on one machine. One programmer is typing in the code. Another programmer sitting or standing next to this programmer is looking for typographical mistakes, logic errors, and is making sure that the person typing the code is following the requirements. Okay, so both of them pair together in a working environment and they both collaborate to work on the code. Now, every 30 minutes or every hour, they switch places, and now the person that was typing will take over the one that is making sure that they follow the requirement. And you can see that this is an intense way of programming. But because two people are focused on the particular code, you will see that the probability of missing something is lower, right? And this type of agile methodology have short iteration cycles, and you can release frequently. Okay, so that's extreme programming in a nutshell. The second type of agile methodology that we are going to talk about is what we call the Scrum. Okay, now Scrum, the origin of the name Scrum comes from the game of rugby. Okay, so if you play rugby, you are probably familiar with the term Scrum. Okay, so a Scrum in rugby means a way of restarting a play after a foul has happened, right? Now, the idea of the Agile Scrum methodology is that a small team, and this is really important, a small team is unified around a single goal, and they get together for sprints of development that move them towards that goal. Okay, so in rugby, after the game is stopped because a foul has occurred, what happens in rugby is a group of players, I think it's about 8 of them, will take the ball and try to move it towards the opponent's goal line. That's what Scrum means in rugby, right? Now, for our software development is the same thing. We have a small team, and that small team is focused on one goal, and they work on this goal in what we call sprints. Sprints, S-P-R-I-N-T-S. A sprint, like they are dashing towards a goal. So they work in sprints, right? And these sprints move them towards the goal of the particular sprint. Okay, so they are sprinting towards a particular goal. That goal can be an iteration, is always an iteration of a particular part of the project. All right, now a Scrum is characterized by the sprints, which is an iteration between 1 and 4 weeks. Okay, so each sprint, since it's called a sprint, you can already know that it's going to be a fast process. So, depending on the organization you work with or you work for, a sprint can take anything from 1 to 4 weeks, right? The sprints that I'm more used to takes between 2 to 3 weeks, right? So there's a sprint every 2 or 3 weeks. Another sprint starts. So the goal of the sprint is to take a small part of the project, just like we talked about. If this is the whole project, just take a small part of the whole project, which is like a feature, and deliver this small part in 2 to 3 weeks. That's a sprint. Then you start another sprint, you develop another feature, start another sprint until you etch at every part of this project and you finish them. So each iteration is one sprint. All right. Now the output of a sprint is the work that the team can accomplish during that sprint. Okay, each sprint will always deliver a usable product. And for a sprint, now the old sprint and the old scrum is managed by a scrum master, right? That's who, the person that manages the scrum is called the scrum master, and he or she is most likely not a developer but somebody that is versed in project management, so that they can coordinate and make sure things happen the way they are supposed to happen. All right, so this scrum master is involved in creating the sprint, and there is a daily stand up. We call it a stand up meeting for the sprints. For the sprint, there is a daily stand up meeting. Now, it's exactly as it sounds. You are literally standing up and you are talking about the progress of the sprint. Is usually 15 to 30 minutes of meeting on your feet, talking about how the whole sprint team, the whole scrum team is meeting together, standing up, discussing how the sprint is progressing. So it's not a time for chit chat or a time for pleasantries, because there are three things that you must give an update of during each sprint meeting, right? What you did the previous day or the previous time you met for the sprint meeting, what you are trying to accomplish presently for that day, and any impediments or anything that might stand as a problem for you not accomplishing what you think you want to accomplish. Those are the three things that you have to bring to a sprint meeting. So you can see that it's a highly focused meeting that pushes each of the team, the Scrum team, towards the goal for that sprint. All right. So with these two types of agile methodology, you can see that speed is the most important factor, but not at the detriment of quality, because the speed, you have removed the issue of documentation. You have people working in pairs to be able to create a software. Then you have a group that meets for 2 to 3 weeks, create a feature, another 2 to 3 weeks, create another feature. You can see that speed without sacrificing quality is actually the aim of your agile methodology. And with this methodology, you can see that you can go through the methodology and be able to release more software products frequently. Any question? All right, so basically what we have tried to do is we have tried to look in depth into the life cycle methodologies. We started talking about the traditional based, your waterfall, and then your waterfall with feedback. Then we found out that there were shortcomings of these two life cycle models. We discussed what the shortfalls were for the waterfall. It's only one direction, and there are no opportunities for looping back or backing up, right? And then we said that an improvement was made, and there is now waterfall with feedback. But even this, we found out that it could mess up our schedule by us going back, and then we have to keep going back if there's something that we find that is missing in one of the phases. This, apart from messing up our schedule, can also mean that we never know when things are completed. So we began to make a case for an iterative or incremental type of model. And we said that an iterative model will take a slice of the software you are building and then iterate through the phases of the waterfall model, use that as a mini project, deliver that to an internal stakeholder, then go to another slice, iterate through those phases again until you complete all the phases. So we made a case for the iterative model, and we talked about extreme programming as a poster child for traditional iterative models, and this gave rise to the agile methodology. And in the agile methodology, we saw how things progress speedily, right? Scientifically speedily. And then in that particular conversation, we talked about extreme programming and Scrum. So you have a wide view of all the methodologies that are available to you. So let's say, for instance, you go for an interview and someone asks you, what type of software development process are you comfortable using? You should be able to talk confidently, because you know all this model, and you know the one that I've told you, the ones that is preferable by companies that are successful. Companies, they gravitate towards the agile methodology, and you can see why this is. They have faster time to get to market. Their products do not stay in the bureaucratic channel of the traditional model, right? So people would ask you in interviews if you are familiar with the agile methodology, right? When you say yes, you should be able to back it up with conversations, intelligent conversation about the type of agile methodology that you are actually comfortable with. Okay, now apart from interviews, from a knowledge standpoint, it's important that when you start developing your software, you be able to choose the right life cycle process that is applicable for that software. And with that, I think this is a good place to put a peg on our class so that we can continue in the next class. Now, in the next class, we are going to start talking about the universe of data. Because now that we have built a good foundation on on how the computer is structured, talking about software development, talking about the life cycle process to help us produce good software, excellent software. Now we are going to start diving into our own domain of the world of data, right? And from there, we would now go into programming databases itself. So that's what's in the horizon, right? And I would implore us to start looking into this in our private classes. So does anybody have anything to add, subtract, questions, or any of those sorts?